Okay, in this current section, we will review the concepts in the main lecture and we will solve some problems, relevant problems. So, in this week, we learned Rn and we know that how to add and subtract vectors. So, if vector is given by this form, then we can add two vectors and we can calculate scalar multiplication like this. By combining these two properties, we can see that v minus w is also equal to v1 minus w1 plus, v minus w is equal to v1 minus w1 and vn minus wn, like this. And the norm of the vector is given by this formula, and it is a dot product, and we also learned what the cross product is. So we wanna solve some problem we wanna solve this problem. So if u and v are given like this, we wanna find u plus v and 4 times u minus 2 times v and norm of u and dot product and cross product. So let's start together. So u is, first we wanna find u plus v. It is just the addition of each coordination. So it is a plus 5, 1 plus minus 2, minus 4 plus 1. So it is 13, minus 1, and minus 3. And 4 times u minus 2 times v is equal to, first we will find for u and minus 2v. Okay, so for u is 4 times u. U is 8, 1 minus 4, and minus 2 times v. V is 5 minus 2, 1. When you calculate the scalar multiplication here, we just multiply by 4 to each component. So it is 32, 4, and minus 16. And it is minus 10 plus 4 and minus 2. Okay. So it is just 22 and 8 and minus 18. Okay. Cool. And then we want to find the norm of u. You can calculate it by using the formula like u1 square plus u2 square plus u3 square of it here. Here u1 is 8. This is u1 and this is u2 and this is u3. So we can calculate it like u1 square is 16 plus 1 plus 16. So it is, just a minute. Yes, so it is 9. Okay, and we want to find u, the product with v. So u and v here, and the product is this one times this one. First, the 8 times 5 plus the second one, 1 times minus 2, plus the last one, minus 4 times 1. So minus 4 times 1. Okay, so it is 14 minus 2 and minus 4, so it is 34. And U cross product with V is, we first write down like a determinant of 3 by 3 matrix like this form. But here we use IJK notation. As we learned in the lecture, I is 1, 0, 0, 0, and J is 0, 1, 0. K is 0, 0, 1. Okay. So here we put U vector here, 8, 1, minus 4, and V vector 5, minus 2, 1. And we can calculate it like I to the 1 minus 4 minus 2, 1. It means that if we choose I, then we can delete this row and column, then we have this matrix here. Okay. And then minus J. Here, minus sign is important. So if we take J, then we can delete his row and column which contains J. So we have 8, minus 4, 5, 1. Okay, this matrix. And again, plus K. Wait here just a minute. If we take K, then we can delete these row and columns, so we get this matrix. So matrix is here, 8, 1, 5, minus 2. Okay. So the important thing is this sign is plus, minus, plus. Don't forget it. So let's calculate it. So I times determinant of this 2 by 2 matrix is just the 1 times 1 minus this minus 4 times minus 2. So I will write down here. Okay, here A, B, C, D. The determinant is AD minus BC. You need to know this formula to calculate the cross product. So in this case, we know that 1 times 1 is 1, and minus, we can calculate the minus 4 times minus 2 is 8. And minus J times, we have 8 times 1 is 8, and minus 4 times 5 is minus 20. And plus K, we have 8 times minus 2 is minus 16. And minus 1 times 5 is 5. So we get minus 7i and minus negative 12j plus, minus 21k. Okay, so it is minus 7i plus 12j minus 21k. And we also can say that you can finish the solution here, but if you want to change this form to the this coordinate representation, then you can say that I is 1, 0, 0, and 12 times 0, 1, 0, and K is 0, 0, 1. So it is minus 7, 0, 0, and it is 0, 12, 0, and 0, 0, minus 12, 1, 21. So it is minus 7, 12, minus 21, like this. So our cross product is this vector. And you can see that if you finish this solution, then you can just get a coordinate representation by writing the these coefficients like each entry like this. So we solved the problem 1 of the first problem, and here problem 2, as we see before, we can say that this for I minus 3j plus 2k, this form is just the 4 minus 3, 2. And this form is 2. And here no j's term, there is no j's term, so here is 0. And here is minus 4. Okay, so you can practice this problem by the same method of this problem. Okay, so I will skip the number 2. We can practice it. And then we learn the proposition. This dot product is given by the norm of these two vectors and cosine theta. So by corollary, we have the equation like this. So we can calculate the theta. Here theta is the angle between two vectors. So if we know two vectors like v and w, and we can find this theta by using this equation. And also using the cross product, we can find the theta by using this equation. Okay, but you know that cross product is only hold on in R3, right? The dot product is defined in Rn, but we know that this cross product is only hold for R3. Also, maybe you notice that dot product is more easier than cross product. So when you want to find the angle theta, then it is this equation is easier than this equation. Because if you want to calculate this cross product, then you need to find some determinants many times. But the dot product is just the multiplication and addition of scalars, so it is much easier. Okay, let's go to the problem 2. Here you need to find the angle between two vectors. The first vector is like this, so maybe you are familiar with the coordinate representation, so it is u is just a 4 minus 3 and 1. Here v is equal to 2, 0, minus 1, right? So if we find u dot v, then it is 4 times 2 plus minus 3 times 0 plus 1 times minus 1. So it is 8 minus 1, so it is 7, right? And we need to find the norm of each vector. So this norm is root of 4 square plus negative 3 square plus 1 square. So it is 16 plus 9 plus 1. So 26. And v is given by 2 square, 0 square, negative 1 square. So it is 4 plus 0 plus 1, so it is root 5. So by our equation, cosine theta is given by u dot v over the multiplication of these two norms. So we know that 7 over root 26, root 5. So it is like a 7 over root 1/3. Okay, you don't need to find the exact value of theta. It is just the arc cosine 7 over 130. I'm not sure you learned this notation, but it is just the inverse function of a cosine theta. So if you do not learn this notation, then you can stop here. Okay. Also, just a minute, we want to find one. Okay, let's think about these three. In 3, u is 9,3 and v is minus 2,6. It is a vector. It is vectors in R2, and we can calculate this dot product in R2. So u dot v is 9 times minus 2 plus 3 times 6. So it is minus 18 plus 18. So it is 0. You know that it is important because if that product is 0, we know the important property here. If the product is 0, then they are perpendicular. So theta is just pi over 2. You do not need to find the some difficult equation. It is just the theta is pi over 2. So they are perpendicular. So if problem asks you check whether two vectors are orthogonal or perpendicular, if you need to check two vectors are orthogonal or perpendicular, then you just need to check u and u dot v equal to 0. Okay, and also if you want to check two vectors are parallel, two vectors are parallel, then you need to check only this. Okay. So from this, we also know the information the two vectors are perpendicular. Okay. I solved 1 and 3 here, so you can check this, number 2. And then you learn some properties of cross products. Here I, J, K is a usual notation of 1, 0, 0 and 0, 1, 0 and 0, 0, 1 respectively. So we can calculate it. I cross product J is K, and also you can check that J cross product K is I, and K cross product I is J. If you draw this R3, and we know that if this is x-axis, y-axis, z-axis, then this is the unit vector I, J, K. And by the right-hand rule, you can check that I cross product J is I cross product J, then our thumb points K direction, so it is K, and J product K is J product K. If you swap like this, then your thumb points this direction, so it is I. Actually, by this corollary, we know that this cross product is perpendicular to both two vectors. So we know that if we calculate J cross product K, then perpendicular the vector perpendicular these two vectors is just the I or minus I. So we only need to find the direction of this vector. So the direction can be determined using the right-hand rule. This rule is explained in the main lecture, so you can use the rule. Yes, so we swap this j from k, then we get the I direction, and if we swap k from the I, then we get j direction. So we know these identities, and by using this property, you can say that if we want to find the k cross product j, then it is the the order is changed, so there must be minus sign here. Okay. So if you want to remember it, then just write down I, j, k, and using this order, if you take your I cross product with j, then it is k, and j cross product k, then it is I, and k cross product with I, then it is j. So it is this direction, this order, so you can remember it easily. Okay. Also, there are some properties like this. You can distributive law here. You can have distributive law. And here we have this equation, this identity. And from this identity, we know that V dot product with VW is 0. Because here if we put V, then it is V1, V2, V3, and by the property of determinant, if these two rows are the same, then this determinant must be 0. Right. So using these properties, we can calculate this cross product, not using the determinant directly. So let's see. For the first one, we want to find I, j, and k here. We know that I times j is k, and cross product with this itself is just 0. Because when you think about the ijk here, and v1, v2, v3, v1, v2, v3, it is the v times v. So in this case, by the property of a determinant, we know that these laws are the same, so determinant is 0. We know this property. So yes, we can add one property, let's say for here. So if we calculate the same cross product with itself, then it is just 0. We can add one property here. Okay. So by the property, we can say this one directly. And let's see the next problem. I cross product with I cross product with k. Okay. So we know that k cross product I is j, right? So I cross product with k is minus j because the order was changed. So it is minus times I cross product with j. We know that I cross product with j is k, so we can calculate it like this. Okay, if we want to check it, then you can see that here I is 100, I is 10, sorry. Okay, we can first calculate this one by the definition using the determinant. It is ijk, and our first vector is I, so 100, and k is the second vector, so 0, 0, 1. So it is I times 0001 minus j times 1001 plus k times 1000. So our determinant here is 0 minus 0, so it is 0, and it is 1 minus 0 and 0 minus 0, so there is just minus j, so we can see that it is the minus j here. And so if we want to calculate I cross product with minus j, then you can see that here by definition ijk with here I is 100 and minus j is 0 minus 10. So by definition of determinant, we can see that it is 0, 0 minus 10 minus j, the 1000 plus k, the 100 minus 1. So it is, this determinant is 0, 0, and minus 1. So it is minus k. So you can check that these are the same answer. So you don't need to calculate it using the definition of this cross product. You can check the answer by using only the properties of cross products. Okay. Also, one thing that you can see that is maybe here. You are wondering if how we put minus like this. In this calculation, you can see that if this vector has a minus sign here, then it'll be minus v1, minus v2, minus v3. But we have the same determinant if it has the minus here with plus like this, right? So this minus property, this minus 1 can be calculated like this or like this, okay? So it is the one of the property of cross products. So let's see the last property here, 3. J minus I times k plus k minus I. Okay, let me see. Okay, from the second property, we know that the distributive law holds with cross product and plus notation. So in this case, we can use the distributive law. So here it is j cross product k minus I minus I cross product k minus I here. I first use like this one, okay? And then we can also use the property like this. So it is j times k minus j times I, okay, minus I times k minus I times I, okay? So let me see, this ijk older, j with k is I, and minus j times I. J times I is, it is the backwards, so it is minus k. J times I is minus k. And I times k, you can like this. So k times I is j. K times I is j, so I times k is minus j. And this is just the 0, we know that. Because it is the cross product with itself. So it is I plus k plus j, right? So I, j, plus k. So it is just a 1, 1, 1. Okay. If you are not familiar with how to check this result, like I minus k minus j is 0, then you can think about it using the right-hand rule. So you need to practice more and more to be familiar with this calculation, okay? Cool. So, yes, we can calculate it by using the properties of cross product. Let's see the next problem here. We record that if there are two vectors u and v, and if we calculate the cross product, then this vector is perpendicular u and also v, u and v. I mean, if there is u and v, then u cross product with v is this one, and it'll be perpendicular these two vectors. So we can see that if u and v are not parallel vectors, then it determines one plane containing these two vectors, u and v, and we see that the vector which is perpendicular to this plane pi is just the vector u cross v. Okay, so in this problem, we need to find the vector perpendicular to the plane that passes through the points P, Q, R here. So let me see. So our P, Q, R is given like this, and we need and there is some plane that contain these 3 points. So what we want to do is find two vectors which are contained in this plane. So we can find two vectors like this. So let's say it is v and it is u. Then we can find the vector perpendicular to the plane by calculate this one. It is u. It's so big. Just a minute. U cross product with v. So first thing we need to do is find the vector u and v. And we will find that u is just the u is p, just a minute, r minus p, and v is q minus p. I mean, let's say that there is a 0 origin, and there is a p, and there is a r here. If we want to find the vector from the p to r, like this, p to r here, then you can find this vector by using the OP vector and OR vector. Maybe you learned this method in the physics class, maybe? I'm not sure, but yeah. If you want to find this u, then u is just the this vector plus this vector, okay? This vector means it is PO vector plus OR vector, okay? So we know that PO vector is minus of P vector. PO vector is this one, and OP vector is this one. So it is the, it was changed as the older, so it has the minus sign here because it started with O, but it was started with P, okay? So this vector. And we know that this vector is just the represented by the vector P, I mean the point P here, 1 for 6. So it is just the 1 for 6. And plus 0R. 0R is the point R here. 1 minus 1, 1. 1 minus 1, 1 here. So it is, you can calculate this sum of two vectors. It is 0 minus 5 minus 5, right? So we calculate the u, and v is Q minus P. So our Q is minus 2, 5, minus 1. And P is 1 for 6. Okay, so it is minus 3, 1, minus 7. 3, 1, minus 7. So first we check that u and v vectors, and we can calculate u cross v. It is by definition I, j, k here, and u vector is 0 minus 5 minus 5, and v is minus 3, 1, minus 7. So it is I times minus 5 minus 5, 1 minus 7 here, plus j times, minus j. Minus j times 0 minus 5 minus 3 minus 7, and plus k times 0 minus 5 minus 3, 1. So it is I times plus 35 minus 5 minus j 0 minus 15 plus k times 0 minus 15. So 40i plus 15j minus 15k. So it is 14, 15 minus 15. So we only need to focus on the direction of these vectors. So you can finish like this, or if you want, you can divide it by 5. Then you get 8 minus 8, 3 minus 3. It is also this answer of the question, because the difference between two vectors is just the length of the vector. Okay, we only need to check the only want to find a vector, one vector perpendicular to the plane. There are lots of vectors perpendicular to the plane like this, so you can find only one vector. If you find one vector, then it is done. So you can check it like this. If you don't understand these things, then you can ask me in the office hour or by email. Okay. Now, my office hour is Tuesday 4 to 6 p.m. and Friday Friday, maybe 3 to 5 p.m. It is the office hour for Math 6A. It's my own office hour, and this is a math lab. You can use this one. And this Zoom link is different, so you can check it on the Culture Space. Maybe the Zoom link is in the syllabus of Math 6A. So if you want to ask the question to me, then you can use these office hours. Or you want to just ask questions about Math 6A, then you can also use the other case office hour. I don't know exact time, so you can check it in the syllabus. And also there is an office hour from professor, so you can also ask questions. If your schedule conflict with these office hours, then you can use the user math lab. In this math lab, all graduate students collaborate the math lab, so you can ask questions to graduate students. They can answer the question from Math 6A. So when you solve some questions in homework problems or these problem set in discussion section, then you can also ask it to any graduate students in the math lab. Math lab is 12 p.m. to 5 p.m. and 6 p.m. to 8 p.m. every weekday. So you can use this math lab the Monday to Friday. So there are many resources that you can ask questions. So please use these office hours, okay? In the lecture, we saw that the length of the cross product is given by this one, and this one is the area of this parallelogram. This parallelogram means if it is V and W, then there is a parallelogram like this one. So this area is the length of this vector, this cross product. So when you think about this problem, find the area of the triangle with vertices. Here, P, Q, R. Then there is triangle. And if we want to find the area here, then you can use this property. I mean, if we find the U and V, like the previous problem 4, we check the vector U and V here. And if you have these two vectors, then the parallelogram, area of the parallelogram, this one is given by the length of the two product vector, this one. So if you find the area of the triangle, then it is the 1/2 of this cross product, right? So what you need to do is first find the vector U and V here. And the second one is find the U cross V, and then find the norm of this vector and calculate it by multiply by 1/2. Okay. Actually, we find the U and V in the last problem. It is the same points. So we know that. Sorry, there is some noise. Just a minute. Okay. We know that U here is 0 minus 5 minus 5, and V is -3, 1, -7. Is it right? Just a minute. -3, 1, -7. Okay. -3, -7. Okay. So we know that U and V vectors here. So Did we calculate the cross product here? Okay, cool. We calculate the cross product here. It is 8 3 minus 3. 8 3 minus 3. It was 8 3 minus 3. And so this norm is given by root a squared plus 3 squared plus negative 3 squared. So it is 64 plus 9 plus 9. So just a minute. 82. Okay, so our area of the triangle is just a minute. Why? Oh, sorry. I mean, it was different than my calculation, so I saw that this one is not the one. I mean, this one is 30, 50 minus 50. Here we found a vector perpendicular to the plane, so the length of the vector was not important, so we can use this vector. But at the problem 5, in the problem 5, we want to find the norm of the vector, which means that the distance of the distance of the vector is important, so we cannot divide it by some scalar. So we need to use the original vector here. So 30, 50 minus 50. Sorry about that. 40, 50 minus 50 here. So we get here 40 squared. Oh, it's not good. Minus 50 squares, right? Okay, we can do it. It is 5. So it is 450, and so it is, yes. And actually it is, let me see, 10 times 5, and it is 5 times, so it is okay. So we know that it is 5 squared times 82, so it is 5 root 82. Okay, so our area of triangular is 1/2 times u cross v, so it is 5 over 2 root 82. Okay, yeah. Okay, this is the last problem. We want to find the volume of a parallel pivot determined by these 3 vectors, and we know that volume of this solid is just the length, just the absolute value of this one. So what I need to do is calculate u, the product with the cross product with w. Okay, so first we want to find v cross w. So v cross w is, by definition, it is I, j, k, and v vector is 0, 1, 2, and w vector is 5, minus 2, 5. So let's calculate it. It is I times 1, 2, minus 2, 5, minus j times 0, 2, 4, 5, and plus k times 0, 1, 4, minus 2. Okay, so it is If we find determinant of this one, then 5 minus -4 and minus 3 times 0 minus 8 plus k times 0 minus 4. So it is 9i plus 8j and minus 4k. So it is just the 9, 8 minus 4. So our last step is calculate the dot product with these two vectors. And we know that u is 6, 3 minus 1, 6, 3 minus 1, and the product with 9, 8 minus 4, which is we found in this calculation. So the product is just a calculate multiplication, these two terms, 6, 9, plus 3, 8, plus -1 times -4. So it is 54 plus 24 plus 4. So just a minute. 82. Okay? Cool. So the volume of the solid is 82. Okay. Actually, I'm not good at calculation. I sometimes take a mistake when I calculate the multiplication or addition. So if you find some mistakes in this lecture, in this discussion section, please send me an email. Okay. So, yes, we finished all problems. If you have any question, please drop by my office hour. Okay, see you next time.